What's up, guys? It's your boy, Mr. Roach. Today is Thursday, May 28th, 2026. I'm here today in school. I'm in class. My voice is just kind of on the edge of going out and losing it. So I decided I'm going to record this when I don't have any students. And I'm kind of like teaching the lesson once rather than a few times. And it's just a little bit easier for me to talk rather than projecting. So hopefully this allows me to stick around for the rest of the week and not have to miss any days sick or recovering my voice. So here we go. This is the last lesson of the school year, which is, of course, very exciting. We are talking about area models, Unit 13, Lesson 4. I would encourage you to try some of these ahead of time. You can pause the video and then move me along to make sure you're getting the right answers. You can rewind, of course, if you need to ask questions or go back to things or see something a second time. Know that today is pretty well designed for you to kind of move at whatever speed you want. So we'll get into things here. You'll need a calculator, so make sure you've got one of those at the ready. Daily problem is a recap of just kind of our general probability questions that will help us as we go further into area models that you'll see. So again, I would encourage you to pause this and try these problems for yourself, see how you do, and then when you unpause it, we'll go through the answers here. But assuming that you've tried them, I'll go ahead and talk myself through it. I need to find the probability of pulling out, I should say, these different chips from a bag. And when I do probability, I want some certain outcome that's going to go on the top of my fraction. And then on the bottom of my fractions, I'm going to put the total number of possibilities. That's what I prefer to start with. If I'm looking through this problem, a bag contains 2 red chips, 12 blue chips, that's 14 total, and then 6 more green chips. Gets me up to 20 on the bottom there. I want to know what's the probability of pulling a red. If I said you come to this game, this carnival game or whatever, and you pull a red chip, we'll give you a prize. Well, there'd be 2 ways to win out of the 20 total chips. You can leave probabilities as fractions. That's totally fine as long as they are simplified. Both of those are divisible by 2. Or you can type them into a calculator, which I've got here. Just go 1 divided by 10, not 110, but 1 divided by 10, and then there's your decimal, 0.1. 10% chance of winning. Next one, if you got a red or a green, either of those would allow you a win. Well, now there are 8 ways to win because I'm adding those green chips as a viable option out of the 20 total. Both of these guys are divisible by 4. And I would have 2 on the top, 5 on the bottom, a 2/5 chance of winning, which would be 0.4 or 40%. And then the last question here, you can get anything as long as it's not green. You don't want a green chip, it really means red or blue. There'd be 14 different non-green chips out of 20 is the same as 7/10 or 0.7 in a calculator. So some of you have seen kind of the intro to the carnival games. This would be a good example of a level 1, a level 2, and then a level 3 way of playing a carnival game. Is I have the most chance, I have the highest probability of moving on from not greens, kind of a middle of the road, a little bit less than 50% chance of passing number 2, and then a harder chance of passing level 3. And a reminder, as we're starting to think about our carnival games that we're going to design, you have to beat all 3 levels in order to claim the biggest prize. We'll talk more about that. Some of you haven't seen that yet. I'll talk more about that in the second half of class today. Now, this question is going to be helpful for us in a moment. If we drew out of this bag 50 times, if I got to level 3 50 times, how many times am I going to find that red chip? We've done this a couple of different times in class, but the idea is to take your probability, 1/10, and I'm going to multiply that by how many attempts I have. So if I win 1/10 of the time, what's 1/10 of 50? A couple different ways to do this on your calculator. You could take this decimal that we found in the last one, and you could multiply it. You could also write your fraction out again, numerator divided by denominator, and then multiply that guy by 50. So I'm using a fraction to keep 1/10, or parentheses, sorry, to keep 1/10 together. So hey, figure out what is 1/10 and then multiply that guy by 50. Either way you slice it, 5 times, we are expecting to win. Hopefully you're feeling good about this. Ask me questions if you need to, rewind and rewatch if you have to. We want to make sure that we're feeling good with this kind of like foundational stuff before we move into some harder things. We are going to talk about area models here in a moment after our trivia question of the day. Trivia question today is, what car company was the first to mass produce, is the idea, mass produce a car that exceeded 200 miles per hour? Make your guess. The answer is Ferrari. Ferrari was the first. I don't recommend exceeding even 100 miles an hour, but Ferrari was the first to make a car that was able to do that. Goals today: being able to describe and utilize area models. Kind of just what are they, how do we use them, and why do we need them? And then being able to calculate probability using those area models. So let's get into it. This scenario, the idea that we're talking about is kind of like a carnival game. You'll see down here that I have not very well starred. That was supposed to be a star in green. We're going to ask the same question. If someone plays our game 50 times, how many times do we think that they're going to win? The game is called the purple game. How do you make purple? How do you make the color purple? You would take the primary colors red and blue, and if you get both of them together, you have made the color purple. So we're going to spin this spinner. We're going to spin it round and round and round and hope that it lands on red. And we're going to spin this spinner round and round and round and hope that it lands on blue. And if we get both of them to happen, we've got the color purple. So area models are a really nice and convenient way of kind of mapping this out and figuring out the probability, right? I need to know the probability to answer this question. So I can use this guy, what we call an area model, to figure that out. I'm going to take one side. I'm going to take one side of the kind of larger square here, and I'm going to call this the first spin, spin A. Similarly, I'm going to take the bottom, the side, I guess, of this guy, and I'm going to call this spin B, the second spinner. And at the top, I'm just going to write out all of the possible things that could happen. For spin A, I could land here and get brown. I could land here and get red, or I could land here and get green. Very similarly, for spin B, this guy, I could land on where it is, and I could get orange, I could get yellow, or I could get blue. Now these little squares here, these individual squares would be your different outcomes. So if I'm down here, or I guess right in the middle, that would mean on my first spin, I got red. And on my second spinner, I got yellow. Not the color purple, but that would be one outcome that I could get, is red on the first and yellow on the second. If I was, say, right here, that means that I would have gotten brown on the first spin up above and blue on the second spin on the side. So we're taking like which one of these it points to, and that is our color combination. So see if you can figure out which one is the purple square. That'd be this guy. That would mean that I got red on spin A and blue on spin B. Are there any other purples? Not that I can see, because if we continue to fill this out, kind of starting at the top, this one would be brown and orange. This one would be red and orange. This one would be green and orange. This one would be brown and yellow. Ew, this one is green and yellow. Disgusting. Packers and bison and hornets. Edina, blech. No, thank you. You should lose money if you get that square. And then that last one is green and blue. Now, a couple of questions kind of spread out on this page. Are all of these outcomes equally likely? What do you think? I'm going to say yes. because I only see every combination once. There's no other spot to me where I can get brown and orange. That would happen only one time, if I get brown on the first and orange on the second. There's only one way to get purple, if I got red on the first and blue on the second. So to me, all of these outcomes are equally likely, and they all have a probability of 1/9. There's one square for each color combination, I should say. Sorry for the bell interruption, out of the 9 total squares there. So that would be my odds of getting purple, 1 out of 9. And then the not purple would be these 8 right there, would be 8/9. So I can go back and I can answer this question up above, and I can say, all right, if people play the game 50 times, I'd have about 5.5 winners, maybe 6 if you round it up. So that is an area model. Again, you want to make sure that you're feeling good about this. Make sure you rewind if you need to see it again. Call me over if you have questions. We can talk about the area model, specific questions that you have. But we can kind of take it a step further here and now pretend that we have some like deeper level thinking questions, some different scenarios that we would want to talk through. So you're not going to charge people money at our carnival, whatever. We're just not going to do that. So if I'm reading through this scenario, if I am charging for tickets, right? If you come to the carnival and you want to play a game, each ticket is going to cost you 50 cents. So it's going to take 4 to play my game, Making Purple game. First question is answered right there. How much is it going to cost you to play the Making Purple game? $2. 4 tickets at 50 cents each would be $2. Now, another thing is I'm going to award people for winning. So I'm going to give them $5 if they win. We call this expected value. The idea is if I play this game, how much money am I going to make, or how much money am I going to lose? Like, what can I expect to come out of this scenario? So a couple of questions before we get down there. First, this one's really similar to what we just did. If 36 people play this purple game up above, how many of them are going to win? I'm going to take my probability of getting purple. I'm going to multiply that by how many people play. 1/9 times 36. Real similar to what we just did, that thing that just disappeared off the screen. I would go 1/9 times 36. I'd expect there to be about 4 winners. See if you can do this one. How much money am I going to take in from the game? If I charge people, how much money am I making if 36 people play? Well, $2 per person times 36 players would net me $72. Ka-ching. I'm going to be a 100-air here pretty soon. As far as prizes, now let me fix this up here. This should not be $4. It's just 4 winners, sorry. Money is going to come back down here for prizes. For prizes, I'm giving $5 each. And we just said 4 people are going to win this game. If I give those 4 people $5, that means I'm giving out 20 throughout the day. Now here's where expected value comes into play. How much profit am I expecting to make from this game? Well, I'm going to bring in $72. I'm going to pay out $20. Means I'm making $52. Not bad. This is a good time to point out that all of this is theoretical, right? This is just me doing the math, me trying to figure out how much do I think is going to happen. Now, I could make more money if not 4 people won. If like 20 people win, then I'm in trouble and I might lose money, right? This isn't going to perfectly play out like this. Just kind of how probability rolls. It's what I think is going to happen, but my experimental probability might be a little bit different. Now, we are getting close to the end here. I've just got a couple more for you. This one might even be better or more interesting for you to do. I've got 2 spinners, and while the odds of getting blue have gone down, I'm putting blue and red on both of them. So there's going to be more squares that make purple. Another wrinkle that I could do this is you have options. You get 2 spins total. You can spin each spinner once, so you could do 1A and 1B. You could spin this guy twice, so your first spin and then your second spin is there. Or you could spin B twice. So we're going to go through those 3 options. We're going to make an area model for those and see which one is like the best way for you to play. Maybe I turn it on its head and I say which is the best for me if I'm trying to make some money. So the first one we're going to talk about here, I've got the boxes set up for you, is if I were to spin spinner A twice. My first spin on spinner A could be green, could be blue, could be yellow, could be red, and then the same outcome, right? Could be green, could be blue, could be yellow, could be red. So I'm going to go through and I'm going to find what are all of the different color combinations that we could have, right? This first one would be green, 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 blue, green, yellow, and green, red. This one would be green and blue. This one would be double blues. This one would be yellow and blue. And then here's a purple square. Maybe I'll highlight that one. There's one purple square. This one would be another green, yellow. This one would be blue and yellow. This would be double yellow. And this would be red and yellow, so no purple squares there. And then last but not least, green and red. Blue and red, there's another purple square. Yellow and red, and double red. So if I'm making the purple game, this one, I've got 16 total squares. It's 4 by 4 is 16 total squares. And 2 of them are winners. So 2/16 is the same as 1/8. Do you think that would be better than 1/9? Definitely, it would definitely be better. That lower denominator is going to have a higher outcome. 1/9 as a decimal, 0.1. 1/8 as a decimal, 0.125. So your odds have increased ever so slightly. Now I'm going to challenge you. See if you can make your own area model. Notice I don't have those squares set up for you. So you got to think about, okay, well, how do I set this up? What is this going to look like? The next one that I'm going to do is spin B twice. And then we'll do one more as spin each one of them once. So hopefully you've tried this. If I'm spinning B twice, my options for the first spin would be green, blue, or red. Green, blue, or red. And my options for the second spin would, again, be green, blue, red. Now, if I'm looking at this, a smaller square this time, because I've got 3 outcomes for each spin, it helps me to write out on the outside so then I know how to divide up these lines. Here I've got green, 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 blue, green, red, no winners. This one's green, blue, double blue, and blue, red. There's a purple. I've got green, red, red, blue, and double red. So one more winner that we passed. This would even be better yet. This is a 2/9 way of winning. Your area model for this guy should be a little bit lopsided. It's not going to be a perfect square because my spinner A is going to have 4 options again. And my spinner B is only going to have 3. So I'm going to have 4 columns going across the top and only 3 rows going from side to side. So I don't have that perfect square, but area models still work the same. I'll fill these in quickly. If you want to fast forward as I do this, understandable. Here's my first purple square. Not going to get any purple squares here because all of them are with yellow. And I should get one more purple square here. Here's your blue and red combo right there. This one, the total number of outcomes that could happen. There's 12 different outcomes. A 3 by 4 box would have 12 different inside squares. And then I've got 2 winners, a 1/6 chance of winning. So if I'm comparing these all side by side, the second one was 2/9, would be about a 22% chance, and then the last one 1/6, so a 16% chance. So if I'm playing this game, I would like to do this option the most. This would be second best over here. Okay, last question here. This one's already set up for us, which is kind of nice. The idea on this one is you would win if you get the same color twice. So I'm looking through this. I've got 3 orange marbles and 2 blue marbles in a bag, which means I have 5 different outcomes for both of these draws. Important to note that I am choosing the marble and then I'm putting it back in the bag. So I'm not taking it out. I'm not messing with these probabilities. It's the same odds on every draw. So a 5x5 grid means that I've got 25 different outcomes here, and I want to pick out any of these that have a repeat color. So there's 9 right there, and then I've got 4 more down there. It gives me 13 total squares. Can't simplify that because 13 is only divisible by 13 and 1, but that's not going to help. So if I play this game 100 times, how many times am I going to get the same color twice? I'll take my probability, multiply it by 100, 13 over 25 times 100, 52 wins, a little bit more than half the time. Now, this is the end of my slideshow. Down below that I'm going to start talking about the carnival, but I'll do that live in person in class. We'll get you started on your carnival. For now, check out the homework. This is the last typical homework assignment of the year. After this, it's probability carnival and studying for your final. So let me know what I can do to help. This has been your friend, Mr. Roach, signing off. Peace.